Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 32. And this problem asks us to explain why amino acids are insoluble in the solvent diethyl ether, but N-acetylated amino acids are soluble. So let's look at a general structure of an amino acid. So typically we draw amino acids looking something like this. And we have, oops, let's make that a little bit more pretty. We have an R group and the alpha hydrogen. So we typically draw amino acids like this, but in physiological pH or in solution, in aqueous solution, because of the pKa's, the amine is going to be in its protonated form. The carboxylic acid is going to be in its deprotonated form. So in total, we're going to have a plus and minus charge, but the net charge is still going to be 0. But the thing with this is that naturally occurring amino acids, well, they exist in their salt forms in physiological conditions. So because we have this positive negative charge, this will exist as a salt. So not only does this make this highly polar, but it makes it highly ionizable as well. So if we look at your diethyl ethers, your solvent, so diethyl ether looks like this. So this is only very weakly polar. So amino acids, naturally occurring amino acids that are highly polar and charged will not be soluble or will not dissolve in something that is very weakly polar and uncharged. So therefore, that explains why amino acids are not soluble in diethyl ether. But then if you look at an acetylated amino acid, so if I were to draw the exact same amino acid, then now I'm going to have an N acetylated. So N means off the nitrogen, we're going to have an acetyl group. So now I've altered the pK of this nitrogen. So now in physiological pH 7, this nitrogen is no longer going to be acting as a nucleophile to pick up an extra proton to be protonated because of that inductive pull of electron density away from the nitrogen nucleus onto the oxygen, making this a worse or a weaker nucleophile. So now N-acetylated amino acids, they are soluble in diethyl ether because they're polar. These are just polar, but they're not salts like naturally occurring amino acids. So because now these don't act as salts, they only act as polar compounds, these will be soluble in a more non-polar solvent like diethyl ether.